Good morning class, this is Saurav and today I am going to discuss a very interesting topic, deflection of beam. We will discuss 2-3 questions which have been asked in previous GATE question paper. A very interesting topic and very important topic from GATE point of view. So today in our lecture we will discuss how to approach the questions which have been asked in GATE. A minimum 1 to 2 marks question definitely will come either in set 1 or in set 2 or in both the sets. So let's start with what are the different methods for calculation of deflection of beams. So first method is double integration method, a very old and popular method. Second method is strain energy method, and the third method is moment area method, and the fourth one is Macaulay's method, and last one is conjugate beam method, and sixth one is Maxwell reciprocal theorem. Generally what happens, these two methods have been studied by civil engineering students, and this method generally be used for conventional type problems, conventional type questions. This method is very simple, but we have to be detailed knowledge about SFD and BMD. Without knowing the SFD and BMD, we can't apply moment area method, because we have to draw BMD. And a very simple method is strain energy method and double integration method. But there are certain limitations with double integration method. This method is most suitable for cantilever beams only. Okay, and also suitable for simply supported beam under symmetric loadings. Under what loadings? Symmetric loadings. So students, we will discuss a problem from strain energy method and a problem from double integration method and a problem from moment area method today. So let's start first with strain energy method. So we are going to start with strain energy method. Before applying strain energy method, there is a theorem. Castigliano's theorem. Which theorem, students? Castigliano's theorem. So students, according to this theorem, the rate of change in strain energy with respect to load, gives the component deflection in the direction of force applied. I am again repeating, according to this theorem, the rate of change in strain energy with respect to load gives the deflection under the action of force or in the direction in which force is applied. So here students, U is the energy absorbed by beam, delta is the deflection, and P is the load applied. So generally what happened in case of beam, students, in case of beam, when load will apply, transverse shear load will apply, the beam will bend. Beam will bend. So most part of strain energy in case of beam is strain energy due to what, students? Strain energy due to bend. There must be some shear strain energy, but as compared to bending, we neglect the fact of shear strain energy, because and strain energy due to bending is what? The integration of moment about a particular section to the whole square dx upon 2EI. Here EI is the constant. EI is a complete term known as flexural rigidity. So students, here we are taking a problem related to cantilever beam to calculate the deflection of a cantilever beam subjected to point load at its free end. Applying the method of strain energy, we will calculate the deflection. Here I am taking a very simple example. Suppose I have a cantilever beam of length L subjected to a point load at its free end as shown in figure. This is point A, this is point B. So according to strain energy theorem, what is our equation is strain energy U equals to what? Integration 0 to L moment about x section whole square dx upon 2EI. So students, what I will do, I have to calculate the moment about x section. So what I am going to do here, I am considering a section at a distance x from the free end. So guys, if I calculate the moment about x section, that will come out to be P into x. What this negative sign is indicating here, this negative sign is indicating hogging of beam. What is hogging here? Hogging means, students, suppose I am considering this copy as a beam. If I will apply a load, the copy will bend like this. This type of bending is known as sagging bending moment. If in case of cantilever beam, I have fixed it from here and I am applying load like this, the copy will bend like this. This type of bending is known as hogging bending moment. Hogging bending moment is considered as negative and sagging bending moment is considered as positive. That's why we have taken negative sign over here. So if I use this equation, so U equals to what? Limit is 0 to L, because our length of our beam is L. Minimum limit is 0, maximum limit is capital L. So mxx means px whole square dx over 2EI. So what will come out common? P square upon 2EI 0 to L x square dx. So students, what is happening? P square L cube upon 6EI. I am again repeating P square L cube upon 6EI. This expression has been asked in GATE 2017 in 1 mark. It is not necessary always deflection will be asked by you. Sometimes they will ask about the strain energy absorbed by the beam. So this is the strain energy absorbed by the beam. One thing is clear from here, U is directly proportional to length Q, also proportional to P square. So our target is to determine deflection of beam. For deflection of beam, I already told you about which theorem? Castigliano's theorem. We have to calculate the deflection under which point? Point B. So according to Castigliano's theorem, the rate of change in strain energy with respect to load gives the deflection under the direction of load. Du at what point? B point. So we have to differentiate with respect to the load which has been applied at point B. So students, after differentiating this, P square L cube upon 6EI, we will get delta B equals to PL cube upon 3EI. PL cube upon 3EI. So students, this is the deflection of a cantilever beam subjected to point load at its free end under the action of point load. Using what method? Strain energy method. First we have considered a section at a distance xx from free end. Then we calculated moment corresponding to xx section. Which moment? Bending moment. Negative sign is indicating here hogging. Then we calculated strain energy, then differentiating with respect to force. This question asked in many times in GATE, PSUs, ESCs and SSCs. So students, this is the problem. Now coming to the